Thanks, Sharon, and thanks everyone in the audience for attending today's TIM presentations. My name is Steve DiCamillo. I'm a Technical Marketing and Business Development Manager at LDRA. And I'm joined today by my colleague, Ihsan Salehi, who is a Senior Field Applications Engineer at LDRA. And Ihsan also leads the LDRA Certification Services Face Verification Authority team. In the presentation, we'll be talking about best practices for assurance of MOSA-aligned software components. So here's just a glimpse at the agenda for our talk. We'll start with a brief overview of MOSA, identify a few of the challenges with assurance of MOSA-aligned software, introduce some important best practices for overcoming the assurance challenges, address a few additional considerations with regards to compliance with safety and security standards, and then leave you with a brief summary. Before we dive in, Ihsan, is there anything that you want to say before we get started here?
No, Steve, go ahead.
Okay.
Thank
All
you.
right, very good. All right. So many of you are familiar with MOSA principles and application areas. MOSA has emerged as a pivotal strategy in designing and developing complex systems. MOSA emphasizes modularity, interoperability, and the use of open standards, fostering an environment where components from diverse sources can work together seamlessly. That's the goal. At the heart of MOSA is the principle of modular design, which involves using well-defined interfaces between system components and platforms. This design approach not only facilitates easier upgrades and maintenance, but it also enhances system resilience and flexibility. Another critical aspect of MOSA is the adherence to widely supported and consensus-based standards. That ensures that system components can be integrated and verified with a high degree of confidence. MOSA's focus on a flexible system architecture also allows for incremental addition, removal, or replacement of major system components. And this capability is crucial for adapting to new technologies, changing requirements, and promotes competition and innovation in the marketplace. MOSA principles are essential for achieving interoperability across different systems and vendors. Taking a little bit different look at MOSA, here focusing on acquisition activities, we can see that by and large, these activities, they do align with the MOSA principles we just talked about. A set of activities that are not inherent in MOSA, but that are required for many systems, are assurance activities to assure that systems are designed and verified to operate safely while maintaining security. By performing MOSA activities and assurance activities together, organizations can create systems that are not only robust and secure, but also capable of evolving in response to new challenges and opportunities. Our paper in this presentation will focus on MOSA and assurance activities at the software level. While MOSA principles do offer significant benefits, they also present some unique challenges, particularly in the area of software assurance. Ensuring that MOSA-aligned software components are secure, reliable, and compliant with standards requires careful planning and execution. In practice, achieving seamless interoperability can be very challenging. Components may be designed using different standards or protocols, leading to compatibility issues. Furthermore, variations in the interpretation and implementation of standards can result in slight inconsistencies that hold back effective communication and integration. The integration of third-party components also introduces significant security risks. These components might not adhere to the same security standards or may contain vulnerabilities that malicious participants could manipulate. The use of open standards, while beneficial for interoperability, can also mean that the system's architecture and interfaces are more accessible to attackers, potentially exposing an attack surface. Adhering to relevant standards and guidelines is a fundamental aspect of MOSA, as it facilitates interoperability and reduces vendor lock-in. However, standards are continually evolving, new standards are emerging. Trying to keep up with all of these changes can be challenging. Additionally, if a MOSA-aligned application has safety requirements, ensuring compliance with safety standards becomes even more challenging. Many of the safety standards and security standards require comprehensive system assessments, including certification of third-party components within the system. One of the benefits of MOSA is to improve long-term adaptability of systems through modularity and open standards. As we alluded to before, this does present some challenges in a number of areas, including lifecycle management. Thinking about lifecycle management, systems have to be designed to accommodate upgrades, replacements, and enhancements over extended periods, often decades. Ensuring the components can be seamlessly integrated or replaced without disrupting system functionality requires careful planning and foresight. Additionally, managing the obsolescence of components, particularly as technology evolves, poses a significant challenge. So, addressing all these challenges is crucial for realizing the full benefits of MOSA. This requires a universal approach that includes rigorous testing, comprehensive security measures, practical standards management, and comprehensive lifecycle planning. By understanding and mitigating these challenges, organizations can enhance the reliability, security, and permanency of MOSA-aligned systems, ensuring they meet the rigorous demands of modern technological advancements and landscapes. So we've listed on this slide 4 best practices for overcoming assurance challenges, and we'll explore these in a little bit more depth in the next few slides. The FACE technical standard provides a standardized approach to software architecture for airborne systems, facilitating interoperability across different platforms and reducing the risk of vendor lock-in. By adhering to the FACE approach, developers can ensure their software components are easily integrated with other FACE conformant software components, promoting modularity and flexibility. FACE conformance not only simplifies integration, but also simplifies future upgrades and expansions. The FACE reference architecture defines distinct segments, each specifying how components within and across these segments should communicate with each other. This structured approach ensures consistent and reliable interactions among the system components, further facilitating interoperability and easing integration within the FACE ecosystem. Also important, thinking about the FACE conformance program, that focuses on the API level of the software application and enforces full conformance to all requirements associated with the FACE segment and profile with the application, the segment within which the application resides, and also the profile that's supported. This targeted certification ensures the components meet the necessary standards for interoperability at the API level, facilitating seamless integration within the FACE reference architecture. So one of the other best practices, continuous integration and testing. Employing continuous integration practices is essential for development, including FACE units of conformance, because the integration of UOCs from different vendors must be seamless. The FACE approach facilitates continuous integration and testing by providing clear guidelines and requirements that can be used by third-party code scanning and static application security testing tools for testing individual UOC interfaces, ensuring that UOCs can be combined without issues. Continuous integration practices enable developers to detect and address integration challenges early, reducing the potential for defects and ensuring that the overall system performs as expected. Continuous testing is crucial for maintaining system integrity and reliability, especially in mission-critical applications. Let's talk a little bit about security assurance. The FACE technical standard includes a security profile designed to ensure that open architected APIs adhere to security requirements that do not violate established security standards and guidelines. The profile constrains the OS APIs to a minimal useful set with the goal of enabling assessment for high assurance security functions executing in a single address space. The security profile was developed with several guiding concepts in mind: isolation of security functions, security transformations, and design constraints. The profile enables isolation primarily by allowing separate ARINC or POSIX partitions that can securely separate relevant functionality into unique time and space execution environments. In fact, the security profile requires ARINC 653 support. Security transformations protect the confidentiality and integrity of data in transit and at rest. The FACE technical standard includes requirements for security transformations, such as authentication and encryption, for all applicable segments of the FACE reference architecture. The design constraints further provide protection of data and information flow across the FACE reference architecture. And now the fourth of the best practices, documentation and transparency. The FACE conformance program requires complete and correct documentation of system architecture, interfaces, and components, all crucial for effective maintenance, troubleshooting, and upgrades associated with a FACE unit of conformance. For example, the FACE conformance verification matrix for a PCS UOC includes 37 requirements that have to be fully or partially verified through the inspection of design documents, and those documents need to be submitted as part of the verification evidence by the software supplier. This verification evidence typically includes software requirements documents, software architecture documents or models, software design documents or models, and interface control documents. The documentation fosters better communication and understanding among stakeholders, including developers, FACE verification authorities, integrators, and end users. By promoting transparency, the FACE technical standard helps to ensure that all parties are well informed and can collaborate effectively, contributing to the overall success and adaptability of the system. So now I'm going to hand things off to Ihsan to focus on the safety and security standards considerations.
Thank you, Steve. As probably you're aware, LDRA has been known for a tool and providing tools for assisting certification to the safety standards, specifically DO 170AC and any other associated avionic or automotive or industrial-based standards. When it comes to the FACE certification, usually because of the nature of LDRA LCS, which is the second part of the LDRA, looking at the certification and for and verification and validation for standards, usually the FACE customers or people who are trying to go for a verification authority for their FACE unit of conformance, they are the people who are also looking at the other standards. And what we have seen is what we are going to be sharing here, the challenges and some of the considerations that the people who are developing a FACE unit of conformance and going to go for a certification for some type of a safety standards, they have to be considering. Software development lifecycle is the first one mentioned here. How to adopt a FACE unit of conformance or a MOSA aligned component to basically be able to perform from one environment that was developed to another environment that was going to be that's going to be used. how to perform a safety assessment, specifically when a particular unit of conformance was already certified in a DO-178C environment, and it's going to be used for another environment, and they have to go through the safety certification again, the methods, and specifically the tool qualification. In this case, we are looking at the tool qualification standards such as DO-330, who were used during the development phase of the unit of conformance. And now, since the UOC is going to another system, how they can what they can use for the tool, and what they can use from the previously certified environment. Of course, integration with the DO-178C and correlating the DO-178C and MOSA. Correlating DO-178C and MOSA. We are talking about DO-178C here, but since we are talking about MOSA, we might have actually a hardware component that is going to go to some other safety standard, such as DO-254. The challenge here comes up that the fact that DO-178C mandate you to go looking at the entire system, performing a safety system assessment. While when you are looking at the aligned component of MOSA or phase certified component, they are particular unit of conformance that can go and adapt to a system. The challenges people have been facing is, well, I'm going to be certifying my unit of conformance to this environment for the DO-178C, and we have all the artifacts. And now if my customer wants to use these UOC, can they leverage or use my certification to be able to certify the UOC within their own system? That's a very good and common question that we have been asked. And unfortunately, in the DO-178C environments, you cannot treat a UOC by itself solely as a CUT component, even though you can leverage some of the CUT components artifacts that you can generate from the UOC and sharing it to your customer who are going to have to be certified their system. The second challenge is defining all the software-related component within the ecosystem framework, basically looking at what are the use cases of this particular UOC. A lot of times the UOC has been defined in order to be adapted to the different communication protocols or different type of partitions. And the other side of the basically usage on the customer side, they may only be looking at one particular components of the UOC. How they are supposed to be worried about it if they are going to for a safety assessment, not using the other part of the UOC lifecycle. Basically, its phase when it comes to the verification process, and when a supplier is choosing a verification authority like us, we were looking at each one of those phase UOC by themselves. So one of the consideration that LDRA LCS perform is providing recommendations, and also can help with the consulting or assessments to help the other sides how they can reuse some of their artifacts and documentation that they have generated to be able to use for another environments, and they be able to leverage some of the certification effort that was already done. This basically can be a complex effort, but with the technical knowledge and also the experiences, we can definitely help you to making sure you can transition from one environment to another one and go through the certification successfully. Next slide. So to summarize, thanks to Steve, we basically mentioned how phase and basically the parent standard MOSA can help you with the interoperability and be able to reuse the components of the software or hardware, and how challenging they can become if they are going to for a safety another safety certification. So the best practices that are basically mentioned in this paper was, one is to adhere to the open standards. It's important, and making sure you're following the standards, you're following the compliance, not compliance actually, conformance of the standard, making sure everything that you have to go through the standard is all aligned with the standard, and your software is fully can be certified. The other part is making sure what can you do as a developer, so you can reuse the components of the artifacts you're generating for the particular unit of conformance for phase, for example. Making sure adopting the newer days verification model, looking at the agile process, looking at the continuous integration methods, and be able to automate the testing part. That's very important, specifically if the life cycle of the UOC will be impacted continuously by the feedback you are receiving from your customer. Definitely, security aspects of the software is a issue. So not only looking at the open standards and then the requirements, looking at the security consideration, doing the security assessment, specifically for particular airborne software that are related to and subjected to the DO 326, for example, or DO 352B. It can help you making sure your software have potential, could potentially be certified if they need to be. Basically, enforcing a security static analysis, or SAST, what Stephen was mentioning, can be one. Make sure you're performing the security assessments. They are a rigid guideline that you can adopt. And also the documentation that you provide. Definitely, the documentation that you provide can affect with the future safety and certification, not only for you, but also for the customers that are going to be using your UOC. Using, for example, the data items that DO-170AC provide, and making sure you are using those data items as a subsidiary for developing your documentation for a particular open standard can definitely be helpful to be able to use the artifacts for other safety environments. Definitely, lifecycle management of software is important. Keeping the tracks of all the artifacts, making sure what artifacts could be shared among your customers, what cannot be, and informing your customers that basically the control access for those artifacts can be very helpful when it comes to the future safety for verification and validation effort. That basically concludes our paper. Thanks for everybody for listening. We are happy to answer any questions that you might have.
Thank you, Stephen and Hassan.
Can you talk about the tools that can be used to develop documentation in FACE? Since FACE is more than source code, i.e. model, requirements, other artifacts, what tools have you found to be useful for managing all documentation?
Usually, you need two sets of a documentation tool. One is to be able to provide you all the necessary document, or basically give you a package of a documentation that you can send to this verification authority. That's very helpful when it comes to the basically independent verification validation cycle. And that way, when you have a verification, so you're looking at your documentation, everything that you're expecting to see is there. LDRA can actually help with this TB manager tool. The second type of documentation, I think it's important, regardless of if you are going for a safety or for the FACE certification or not, is the ALM tool that you are using. Showing the traceability, as Stephen was mentioning, it's part of the FACE verification effort that you have to do. That's traceability can also be reused when you go to the safety standard certification. Having those requirement traceability verification metrics that you have to perform for DO-170AC or DO-254 could also help going for face, and even, for example, SOSA standard, where people have to looking at the tiers of a standard and make sure that we can validate their design based on the tiers that the SOSA impose. Hope I answered the question.
All right, thank you very much, Stephen, Hassan, appreciate it.